Alright, in this lesson what we're going to be talking about is how to add and subtract polynomials. But before we get started about adding and subtracting, we kind of need to go over what a polynomial is. So I'm going to give you guys some examples of what's called a monomial. And if you think of mono means one. So if we're thinking of one number, like the number 8. Alright, or if we're using variables, it would be a. Or if we're using a combination of variables being multiplied to letters, or numbers will be multiplied to the variables, like 8a would also be considered a monomial. All right, if I said 4 times x times y times z, these are all considered to be monomials. So these are one number. One thing that's not considered to be a monomial is like 4 divided by x. That would not be considered to be a monomial. But I could say x over 4 is a monomial because you could rewrite that as 1/4 of x. So monomials can be multiplied, like variables and constants are allowed to be multiplied together. You just can't put it in the denominator. All right, so then we have something called a binomial. Bi meaning 2. So if you have two different numbers like a plus b, that's considered to be a binomial, or a plus the number 4, all right, or x plus 8, or 1/4 of a plus 10. These are all binomials because they're two individual monomials being combined. So it doesn't matter if it's adding or subtracting. I could say x minus 7. Those are all binomials. And then we get to something that we will get to when we're dealing with quadratics. We'll get to what's called quadratic trinomials. All right, but trinomials, let's just start with something easy like a plus b plus c. That's a trinomial, 3 different numbers. All right, sometimes you might see a quadratic like x squared plus x plus 6. That's a trinomial. So anytime you have 3 different monomials being added to, that's the case. So let's go ahead and just do a really big trinomial here. Let's go 8x to the power of 4 plus y plus z. So we got a trinomial. Now this number up here is referred to as the degree of the polynomial. All right, so that's considered to be the degree of the polynomial. The degree of the monomial is whatever the sum of all the exponents, whatever their powers are together. So right here we have a 1, a 1, a 1. The degree of this monomial, this degree would be 3. This degree right here would be 1, this degree would be 1, and this degree would be 0. Because on this one, if we have a variable, that's like x to the 0 is 1. So you're looking for the variables. Okay, so let me look real quick. All right, so the degree of a monomial is the sum of the exponents, key thing, of the variable. So to find this right here, you look for the 2, you add 4 plus 3 plus 1, and that gets you 8. And here there's no variables, that has a degree of 0. So make sure you know the difference between the degree of a monomial and the degree of a polynomial, which is just the highest degree. So let's give me a quick little example here. All right, so if I said 4x squared y to the power of 4 z to the power of 3, what would be the degree of this particular monomial? You'd say 2 plus 4 plus 3, and you'd say the degree is a 9. We have a degree of 9. But if I said 4x squared y to the power of 4 z cubed plus z squared, what would be the degree? You'd look for the highest one. So this degree is 4, so you would say the degree of this polynomial is 4. All right, so that's basically what you need to understand. Now, understand anything beyond a monomial, all right, anything beyond it, like no matter if it goes to 4 of them, all right, those are called, or 4 monomials, those are called polynomials. Poly meaning many. All right, so you could have a really long polynomial like x to the power of 4 plus 3x squared plus 2x minus 7. That is just considered to be a polynomial. This would be a quartic function, but it would be considered to be a polynomial. All right, so I just give you some examples of in your journal of what a monomial is, a binomial, and a trinomial. They're all polynomials. Now, if we want to add those together, we can only add like terms together. So we're going to be working through these expressions one by one. When you are working on these, one thing you want to make sure is that you look for the distributive property. You look here, can you combine anything? Since you can't, you got to distribute it to both terms. So here we have 9q squared. And when you multiply negative 2 over 3 times 3q, it's like saying 3q over 1. Now there's a couple ways to do this. You could multiply negative 2 times 3 and get negative 6q over 3, numerator times numerator, denominator times denominator. And eventually you would get negative 2q, because 3 goes into 6, total of 2 times. However, you could also, if you want to, cancel those out, because 3 goes into 3, a total of 1 time, and you still get the same answer. Now, I'm going to go ahead and pause and get my graphing calculator ready to go. So let's just say you're just not good with multiplication and you still have access to a graphing calculator. We can still take negative 2/3 and multiply it by 3. Just make sure you're dealing with coefficients. Negative 2 divided by 3 times 3, and you'll see it's a negative 2. So I just take that negative 2 right here, minus 2, and I'm just going to put a q right there. All right, so I'll go ahead and do that, and I'll do that in green since I started in green. So negative 2q. All right. Now, the next thing I'm going to do is I'm going to take negative 2/3 and multiply it to a negative 7. So I have negative 2/3 times a negative 7. I'm putting negative 7 over 1. Once again, a negative times a negative will equal a positive, and 2 times 7 is 14, and 3 times 1 is 3, but 3 does not go into 14, so I literally have to write plus 14 over 3. Now, if you were to do this in the calculator, you would get 4.6 repeating, and that's not what I want you to type in. So if I say negative 2 divided by 3 times a negative 7, you get this positive 4.6 repeating, but I want it as an improper fraction. Okay, so 14 over 3. And then what do we have here at the end? We have plus 5q squared. Now the only thing you can combine on this problem, is the 9q squared and the 5q squared. You can combine those, which gives you a total of 14q squareds minus 2q plus 14 over 3. And this right here is your final simplified expression. And this would be considered a trinomial. Now, this trinomial, if I said what's the degree, you say this degree is equal to 2. That's the degree of the trinomial, or the degree of the polynomial, because 2 is the highest exponent. All right, moving on to our next question. Scrolling down right here, let's take a look at number 2. All right, we're going to find an expression that is equivalent to this. Now, I've taken away all the multiple choice answers because I want you guys to know how to do it. So we're going to take this 2m. We're going to distribute it into both terms. And we're going to take this 3 and distribute it into both terms. So I'm going to get it all set up how you would do it by hand, and make sure you also know how to use the graphing calculator. So here we go. 2m over 1, that's how you can write it. You can put 1 in the denominator, times 3 over 2. Now you see that m right there? Technically, you could still put that m up here in the numerator if you want. You don't have to keep it down there by the side. So we're going to multiply that together, and that's going to get us a total. 2 times 3 is 6. M times m is m squared over 2, because 1 times 2 is 2. And 2 goes into 6, total of 3 times. So I'm left with 3m squared. So that first part right here, this 2m times 3 over 2m is equal to 3m squared. Now you may have also noticed that 2 goes into 2 a total of 1 time, and 3m times m also will give you m squared. So we're done with that part. The next thing we're going to do is I'm going to do 2m right here, 2m. I'm going to multiply it to 1. Well, 2m times 1 is just 2m. So I'll go ahead and put it right now. Here's what we have so far. Our first products are 3m squared, and 2m times 1 is just 2m. Now I'm going to go ahead and use green here. So we have 3 times 5 over 3m and 3 times negative 2. All right, let's go right over here. Let's do 3 over 1 times 5. I'm going to put the m right next to the 5m over 3. 3 goes into 3 one time. I'm just simply left with 5m. Now 3 times 5 is 15, divided by 3 still gives you the 5, so I'll put plus 5m, and 3 times negative 2 is negative 6. All right. So now we just got to look for like terms. The only like terms we can combine are those right there. So our final answer is going to be 3m squared. 2m plus 5m is 7m minus 6. And that's our final answer. All right, let's keep moving. Oh my goodness, we got a long expression right here. All right, so what we're going to do is we're going to do each of them different colors here. We're going to take 3c, multiply it to both those. Then we're going to take negative 7, or minus, actually it's minus 7. We're going to multiply that minus into both of those. Then we're going to take this positive d and multiply it, this plus d, multiply it into both of those. So this will not take very long. So let's go and start with the blue. So we have 3c over 1 times 1 over 3 times d. Now, if you want to, technically, you can just take that d and multiply it to the 1 right up there. Technically, you could put d over 3 if you want to. And then over here we have 3c times negative 9, or 3c multiplied by negative 9. So what's going to happen here? These 3's are going to cancel out, and you're left with cd, because 3 divided by 3 is 1. 3c times negative 9 is minus 27c. And we are done with that. Negative 7 times c is negative 7c, and negative 7 times 1 is minus 7. So I'll just put negative 7c minus 7. And last but not least, we have d times c. But what I want you to understand, d times c is the same as c times d. Same product, but when we're writing variables, when we're writing monomials with variables, we always try to go in alphabetical order. Okay? And then d times 4 is 4d. There we go. So now we have to look for like terms. I'm going to highlight some like terms. I have a cd right here, and I have another cd. It's positive. So a cd plus another cd gives me a total of 2 cd's. All right, I'll go and put those in orange so you can see how they line up. All right, go ahead and highlight this one in magenta. I got negative 27c minus 7c more. All right, if you're wondering, I don't know, I'm not going to be able to do this. You can still use a graphing calculator. Watch, negative 27 minus 7 more still gets you negative 34, just like negative 27 plus a negative 7. Either way, still gives you a negative 34. You're just adding those together. All right, so we get negative, change this color, negative 34c. And then we have minus 7 plus 4d. Well, I'm going to put the d's first, and I'm going to put the constant at the end. I put the constant at the end, and there is your answer. We have a total of 2 cd's when we add those together. We have a total of negative 34c's right there, so minus 34c. And then we have a plus 4d and a minus 7, and that's your expression totally simplified. So basically, there's two things you're going to be doing. You're going to distribute and combine like terms. That's it. Every single one. Distribute, combine like terms for those. What? The volume of two identical cubes is related to the edge length of the cubes. Which function represents the combined volumes of the cubes? So here's what I want you to do. I want you to say y is equal to the combined volumes. But y is equal to the combined volumes. All right. Now, the volume of a cube, all right, of any rectangular prism is length times width times height. But the volume of a cube is going to be basically the side, whatever the length of the side is, cube, because a cube has all the sides that are the same. So it says our sides are x. So that side's x, that side's x, that side's x. So if I wanted to find the volume of the cube, all right, I just find this, take the side, and I multiply it by itself 3 times. Just remember, x cubed means x times x times x. So this volume is x cubed. That's the volume of this one. And this volume is x cubed right there. If I wanted to find the combined volumes of both cubes, then y would equal x cubed plus x cubed. But because they're like terms, you have a total of 2x cubes. Number one mistake students make is they combine it and they do it incorrectly. They multiply instead of just add them together. If I said x cubed times x cubed, that's a total of x to the power of 6, because this means x times x times x, and this means x times x times x. So you have a total of x raised to the power of 6, because that's how many times you're multiplying it together. But our answer is 2x cubed. So you say y equals 2x cubed. All right, moving down. Whoever did this problem took way too many steps. Okay, so I'm going to highlight what they did. All right, so they did this in the first step. This is their answer for the first step. They did this in the second step right here. And then they did this in the third step. Oh, that's just a lot of steps. I just distribute all the way through first and just take care of that. So we're going to go ahead and do that. By the way, 0.5 is half. Half of negative 12 is negative 6. And half of 6 is 3. So that's me distributing the half to both the negative 12c and the 6. Then we're going to go ahead and distribute the negative 3 to both. Negative 3 times c is negative 3c. Negative 3 times 4 is minus 12. And then 10 times c is 10c, and 10 times negative 5 is negative 50. Let's check their work. Looks like they got the first one right. They distributed that correctly. Looks like they got the second one right. They got that right. And looks like they got the third one right. So they must have messed up here. They must have messed up here. So how did they mess up? Well, let's take some like terms, shall we? Here we go. I've got negative 6c, got minus 3c, and positive 10c. Well, I don't see a positive. Well, if you don't see a negative in front of it, automatically assume that's going to be positive. So what is 10 minus 3 minus 6? Well, if you didn't know that was 1, you could still use the graphing calculator. Negative 6 plus negative 3 plus 10, and voila, you see it's a 1. So right here, we're just going to say that's a total of 1c. But technically, we can just write c. We don't have to put 1c in front of it. All right? Just like if your name was Johnny, people wouldn't say, hey, how's it going there, one Johnny? They just say, how's it going there, Johnny? So we have 1c, which is just c. Now let's take our constants and add our constants together. We've got a 3. We've got a minus 12. We've got a minus 50. Well, if you didn't know that was negative 59, you could still use the graphing calculator. All right, and do 3 minus 12 minus 50. There you go, minus 59. All right, so all we're going to do is we're going to put minus 59. That's the correct answer. So you can see they messed up here. So which step did they mess up on? Which does it first appear they simplify the expression? They messed up on step number 4. They did everything right. They just were not able to combine like terms. All right, 2 more questions. So all we're going to do right now is we're going to make a couple of rectangles. And we're going to label them. One rectangle has a length that's called ABCD. It says ABCD has a length represented by 5x minus 1. So I'm going to put 5x minus 1. And a width that's represented by 3x plus 7. So I'll put 3x plus 7. Now, one thing about rectangles that you should know, besides that they have 90 degrees in all their corners, opposite sides are equal. So if 5x minus 1 is the length, then over here, that's going to have the exact same length. And if the width is 3x plus 7, then I know this width will also be 3x plus 7. Well, that makes it easy. And it says rectangle JKLM. And when you're ordering this or labeling this, make sure you just go Just go clockwise, okay? Makes it a lot easier. And it says it has a length that is 2x minus 5. So I'll put that in both areas of the length. And it has a width that's 4x plus 11. Now, I'm not drawing this to scale. All I'm doing is just writing the expressions. Okay? So now, all we have to do is, it says which expression can be used to represent the sum of the perimeters. Like, well, what does it mean to have the sum of the perimeters of both rectangles? It means you got to add everything up. Go all the way around on both rectangles. All right? So let's go ahead and add all our x's together. Got 5 and 5, which are 10. 3 and 3, which is 6. That's a total of 16x. Got 7 and 7, which is 14. 14 minus a total of 2 gives me 12. So the sum of all the sides in the blue of A, B, C, D is 16x plus 12, because I just added all the x's together. If you didn't see that, took 3x and 5x, which is 8x, plus 3x plus 5x, which is another total of 8x. And 8 plus 8 is 16. That's another way of looking at it. And then I just took all the constants and added them up. All right? 7 plus 7 is 14, minus 1 gives me a total of 12. All right? Let's take a look at the red. All right, we got 2 and 4. That's a total of 6. 4 and 2, 6. That looks like we're going to get a total of 12x. If we just add those x's together, you can kind of see that. Ready? 2x, and 4x, and 4x, and 2x adds a total of 12x. All right. If I'm going too fast for you, you just need to learn how to add and subtract. It'll be a lot easier for you. And then let's take a look at some of our constants over here. So I've got 11 minus 5, which is 6. And I got another 11 minus 5, which is 6. And 6 plus 6 is 12. So I got 12 again. Now you can use the calculator if you need help calculate. And then we just add our variables together. 16x plus 12x is a total of 28x, and 12 plus 12 is 24. That's why the answer is C. If you added 16x plus 12 and 12x plus 12, x's go with x's, constants go with constants. And it's as simple as that. So all we do is basically just add like terms. That was it. Okay. All right, and last but not least, okay, what we're going to do right now is we're just going to show you guys how to use the graphing calculator to help you with the multiplying of decimals. So we got 2.5, multiplying it to both of those. We've got negative 3.6, multiplying it to both of these. And then we have a negative being multiplied to both of those. So here we go, 2.5 times 4.2. 2.5 times 4.2. It's a total of 10.5. So right now I'm going to write 10.5x. Then we do 2.5 times 7.4. Ooh, 18.5. So I'll put plus 18.5. All right, got negative 3.6 times an 8, so negative 3.6 times an 8, negative 28.8. Put an x. Then we have negative 3.6 times another negative, which makes it a positive. It's going to be 3.6 times 4.5, but I'll go ahead and put negative 3.6 times a negative 4.5, and I get 16.2. Put a y. And then the last one's the easiest. You just multiply a negative to both. So negative times 2.4x is minus 2.4x, and negative times a 6y is a minus 6y. So now all we have to do is just add like terms. I'm going to keep all of my x's blues. So we got a blue right there. Scan another blue right there. Scan another blue right there. So I'm going to add all of my x's. So I get 10.5 minus 28.8 minus 2.4. Here we go. 10.5 minus 28. Oh, not 25. 28.8. Right? Minus 2.4. Okay. We get negative 20.7. So I'm going to put minus. I'm feeling pretty good about that. Okay, now let's take a look at our y's. So I'll kind of switch over to red. Scanning, scanning, scanning. Here we go. Y is right here and right there. So 16.2 minus 6. 16.2 minus 6. And we get 10.2. So I'll put plus 10.2. Oh, you know what? I forgot. Right here. Forgot a y. Whew, good thing 2.5 times 7, that was 18.5y. Whew, that was a close one. I better add 18.5y to that. So I better add 18.5, which gives me 28.7. That was a close one right there. So I'll put plus 28.7y. Alright, so I made a quick little mistake, but it didn't impact my final decision because I had to look back and realize, oh, I did 2.5 times 7.4y. I forgot to put the y down. So make sure that you just check your work before you select your final answer. This final answer was and is G. Alright, so in review, when you guys are working on this, make sure that you are doing two things. So here's the two things you want to do. When you see the distributive property, step 1, you want to distribute wherever you need to distribute. Okay? And make sure you distribute correctly. And step 2, combine the like terms. And that's it. Alright, so hopefully you took some notes. You have a better understanding of different characteristics of, for example, what's a monomial, what's a binomial, trinomial, what's considered to be a polynomial, and dealing with degrees of polynomials and also degrees of monomials. You'll have a good day.